bases.
So that's why they are bases. Uh, so usually metal oxides. I mean, because a negative ion has to have a positive ion with it, right?
Yep.
You can't just have an oxide ion just roaming around. There's going to be a positive ion sticking to it, and most of the time it's a metal ion. It's going to be a metal oxide or a metal hydroxide or
Metal.
or a metal
Carbon.
carbonate, right? Uh, these are all bases. This is not a very good base actually. Carbonates are weak bases, which means that they don't really like to gain H plus one ions that strongly. Uh,
Okay.
so they're weakly basic. Oxides and hydroxides are pretty strongly basic.
Okay.
But it's not limited to these. These are the only ones that we'll study. Anything that accepts H plus one ions, that's a base. Okay?
Okay.
If any random molecule accepts H plus one ions, that's a base. And remember, it's the acceptance of H plus one ions, not just any H. Not hydrogen. We're not talking about hydrogen gas over here. It has to be the H plus one ion that
Okay.
needs to be accepted. So the other
Okay.
thing, so this is bases. Did we talk about? So we actually didn't talk about acids. We
No.
talked about bases. So I'm going to talk about acids now.
Okay.
Which compounds are acids? Acids are compounds that I mean acids produce H plus ions, right?
Yeah.
They're proton donors. So they're proton donors. They produce H plus ions. Now,
Okay.
now the only way they can actually produce H plus one ion is that they have H plus one ions. That's why. That's why.
Yeah.
So the,
Okay.
so the positive ion is going to be H plus one ion plus. I mean, any acid has this particular formula that there's going to be a positive ion attached to some negative ion. Let's call it A, negative ion.
Okay.
Okay, does that make sense?
Yes.
Okay, so any compound that has two ions, one is H plus one,
Mm.
so the other one must be some negative ion, some random negative ion.
Okay.
So you have HCl. Now in HCl you have the H is the plus one and the Cl is the minus one. It's group seven, right? What is the
Yep.
name of this acid? It's called hydrochloric acid.
Hydrochloric acid. Yeah.
Okay, it's a very common acid. Then you have sulfuric acid, which is
Okay.
H plus one, and sulfate. It's attached to SO4 minus two. Okay, can you hear me, Afif?
Okay.
So H plus one with SO4 minus two. What would be the formula? It's going to be H.
It's like it's you kind. Your voice is kind of unclear.
Huh? Nee, what did you say?
Hello.
Yes, yes. What did you say?
Hello.
Hello, can you hear me?
I can't really hear you. I can't really hear your voice. Really glitchy.
So right now it's. Let me try and do something. Can,
I can't really hear your voices.
can you hear me properly
Okay.
now? Can you hear me?
Yes. For now I can.
So H plus one with SO4 minus two.
Okay.
So these two, it's going to form H2SO4.
Yeah. Okay.
So you get me crisscross, it's H2SO4.
Okay.
This is your sulfuric acid.
Okay. But up here for the basis one, you also put there's also a H plus ion and it's also H1 negative ion.
Where? I mean, in this
When
OH?
you put the bases, oh wait, yeah, OH is going to the H, and that's still a negative ion.
Yeah.
So how is that not an acid?
I mean, specifically talking about this one, right?
Yeah.
The first thing is accepting H plus one ions, so it's behaving as a base. ठीक है? The
Okay.
the other thing is your question, I think, is that you're saying that there's OH minus one.
Mm.
Why can it not lose an H plus one ion?
Yeah,
I mean, that's definitely a possibility that it could lose an H plus one ion, right? But
yeah,
but do you think a negative ion would actually attract an H plus one ion, or would it lose an H plus one ion?
attract one.
So I mean, there's the chances of it actually losing another H plus one ion. That's kind of
Very
remote.
low.
Yeah.
Okay. Wait, and but okay. Yeah, that's fine.
Okay. So I mean, it is a possibility. It could lose an H plus one ion, but it's not going to happen.
Yeah, okay.
So then, moving on, the next acid that we need to remember is there's a nitric acid. It's H plus one combined with NO3 minus one, a nitrate
Okay.
ion. So it's I mean together they're going to form HNO3. So this is your nitric acid,
Okay.
and you also have phosphoric acid, which is H plus one combined with PO4 minus 3.
It can be 3 HBO4.
So it's going to be H3PO4.
Yeah.
This is your phosphoric acid.
Okay. Do we need to remember all these?
Yes, you need to memorize them. Let's just do
Okay.
five. I mean, there's a carbonic acid as well, which is H plus one plus a carbonate
C.
ion.
Okay.
So the formula of the acid would be H2CO3.
Okay.
And this is your carbonic acid.
Okay.
I said, remember these ions over here? I mean, combine H plus one with any negative ion. It's going to be the
Yeah.
acid. Okay?
Okay.
I mean, if you find any negative ion, just combine it with it. It's definitely going to be an acid.
Okay.
So,
Wait, but see, yeah. You see this carbonic acid, okay?
yeah,
Isn't that what like rainwater is? Because like the CO2 in the air and there's H2O in the H2O in the water.
yeah,
So when the water mixes with the air, then that comes carbonic acid, right?
yeah.
And is that why it's like but it's quite weak, isn't it? Because then that's how like you have weathering on like rocks and stuff,
No,
like
but it's,
limestone.
I mean, TK, your point up to this point is correct, actually. That carbon dioxide combines with water
Mm,
and they combine to form H2CO3.
yeah.
But carbon dioxide doesn't really like to do that. I mean, most carbon dioxide is very weakly soluble in water. So
Mm,
not a lot of carbonic acid is actually going to be produced this way.
okay.
Okay. So
But
it's not responsible for the whole pollution problem.
no, but I want like acid rain.
It has nothing to do with acid rain. Uh,
Oh, okay.
I mean, acid rain is caused by some other gas. I mean, this is actually going on, but it's not that big of a problem. Firstly,
Okay.
I mean, carbon dioxide is not very soluble in water, so it doesn't happen that much. There's another pollutant which is SO3,
Okay.
and that reacts with
Sulfur.
water to form H2SO4.
Okay.
So it's actually the acid rain that you're talking about is caused by this thing.
Okay.
And where do you get this? This is the sulfur. This is combustion of fossil fuels, especially the
Okay.
the unclean fossil fuels. Like coal has a lot of sulfur in it.
Yeah. Okay.
So a lot of thermal power plants would be combustion of fossil fuels.
Okay. But like for example, cars don't give that off, do they? Because the
Cars are probably cleaner because gasoline is
yeah.
is very well refined.
Yeah.
So
Okay.
so cars are relatively cleaner. Now you have hybrid electric cars, so that's not an issue. Uh, but your big ships, your diesel, not even diesel, it's coal is the main culprit. And not only
Okay.
just coal, it's actually just a simple volcanic eruption
Mm,
that produces a lot of sulfur dioxide. Sulfur
So how
trioxide.
why is it called so why is it called sulfur dioxide?
Nee, this is sulfur trioxide.
Dioxide. Oh, I think I heard you wrong.
I mean, there's actually. I mean, it starts off as sulfur dioxide
Yeah,
when
and then it connects
sulfur
to
is,
another oxygen.
and then it in the air it after spending time in it, it combines with oxygen to form sulfur trioxide.
But
And
that should be SO4.
the but you can balance this, make it 2SO2.
Oh, okay,
Okay.
okay,
So it forms SO3. So I mean,
okay,
there's no gas as SO4 because
okay.
sulfur would run out of electrons
Oh
when
yeah,
heat.
okay.
I said anyway. So this is it's not carbon dioxide that's responsible. Carbon dioxide is this thing is your acid in your sodas and your Pepsis and your Cokes.
Okay.
So
Is that
this
the
is
thing that makes the fizz?
hmm?
So that's the thing that makes the fizz.
Yeah. I mean because under high pressure these two combine. Like
Okay.
I mean the bottle is really pressurized, right? The can is pressurized.
Yeah.
So under high pressure these two combine and they form this thing. So there's this acid. As soon as you release the pressure, the carbon dioxide gas starts. I mean they start
To separate
un-
from the water.
to separate from the water. So you start
Okay.
seeing those bubbles forming,
Okay.
and they even further separate. Uh, they even further separate when you drink them, right?
Mm.
Where's this reaction? As so when you drink, uh, your stomach has a lot of acid in it.
Okay.
Okay, so I mean that's the first
Yeah.
thing. Carbon dioxide gas would be released, but if you drink H2CO3 and like that acid goes into your stomach, and it has
Mm.
CO3 minus two ions, CO3 minus
Mm.
two ions they combine with the acid in the stomach, and
Mm.
they also start reacting and they start producing carbon dioxide, which is why you start burping a lot after you drink a fizzy.
Okay. Okay.
Okay, so this is carbonic acid.
Okay.
So now so the simple idea is any ion, any negative ion
Mm.
combined with H plus one, that's going to act as an acid.
Okay.
So now the other thing is let's start with some reactions. And there's a third thing which is a salt. Okay, what's a salt? A salt is something when an acid is neutralized, or it's formed when an acid is neutralized.
Okay. What about when so so like is that when you put alkaline into an acid, or is it or it can also be when you put acid into an alkaline?
Isn't it the same thing?
Yeah, same. Okay, that's just both, right?
You're saying that I didn't get what your point was.
So an acid is neutralized, yeah. Both when the acid gets put in alkaline and when the alkaline gets put in acid, in both cases getting neutralized.
Yeah, it's the same reaction.
Okay.
Okay. So
Okay.
salt is formed when an acid is neutralized. What does that mean? Like if you have HCl,
Mm.
I mean the basic idea is a salt is something that doesn't do anything to an H plus one ions or OH ions. It's
Okay.
it's not going to affect doesn't affect it's not going to affect the H plus one or OH minus one concentration.
Okay.
Okay, no effect on that. Like the acid increases H plus one, the base decreases H plus one. It doesn't do anything. Uh,
Okay.
so it's a neutral compound.
Okay.
It's not going to affect pH. No change in pH would happen.
Okay.
I said, but how is it formed? It's formed when an acid is neutralized. For example, if you have HCl, why do you think HCl is an acid? I mean, if I need to neutralize it, neutralize means to stop it acting as an acid. Which ion should I get rid
Yeah.
of?
Um. So from I to get the H, you need to get rid of the H.
Get rid of the H and replace it with any other ion like Na+1.
Yeah.
So that's your salt.
Okay. So it displaces the H.
Yeah, so just displace the H. H2SO4.
Okay.
The salt would be somehow neutralize it. Get rid of the H
Mm.
and let's say MgSO4, right? So
Okay.
so it could be anything, KCl. You could replace it with aluminium. Just make sure the formula is right. Aluminium is +3, so it's Cl3. So any MgSO4, Na2SO4, Na is +1, SO4 is -2. Just
Mm.
get rid of the H and displace it with any other positive ion.
Okay.
Okay. So now in a reaction, you're not going to just put any positive ion. You're going to put the positive ion that's available to you in the reaction.
Yeah. Okay.
So get rid of H+1 in acid and you displace it or replace it with any other positive ion. And it's usually a metal ion.
Okay. But it's not always a metal line. It can
Yeah,
be non-metal as
any
well.
positive ion. It could be NH4+1 as well.
Okay.
So any other positive ion, and it could be most likely a metal ion.
Okay.
So that's what you're going to do. So for example, I'm going to start with the first reaction. The first reaction we're going to do is there's a reaction that if you react a metal with an acid,
Mm.
salt and hydrogen gas are produced. These two gases are produced in this reaction. So
Okay.
metal plus acid produces salt plus hydrogen
H2.
H2 gas.
Hydrogen. Okay.
Uh, Now we need to let's pick Mg metal. That's HCl reacting with it, right? Uh,
Mm.
how did I tell you a salt is produced? A salt would be produced when the H
When you
gets
get rid of the H, yeah. Get rid of the H plus sign.
so and who's going to take its place? Mg.
Mg.
And Mg is in group two, so it's Mg's. I mean, it's going to be MgCl plus the H is going to be displaced, and it's going to form
Yeah.
hydrogen gas. Okay, you're going to write hydrogen gas irrespective. I mean, right now, initially, ignore that there's only one H getting displaced. You do the balancing at
Okay.
the end. I mean, first thing is you make the formulas.
Yeah. Okay.
So you have to make this formula as well. I mean, there's Mg2 plus and there is Mg is group 2, so it's 2 plus, here is -1. So the formula over here is going to be MgCl2, right? Is this clear?
Yeah. Okay. Yeah.
So now the formulas are clear.
And then it's gonna be two HCl because there's two chlorine and there's two hydrogen as
Now the first thing is you make the formulas.
well.
The
Okay.
next thing is you balance it. Now, once the formula is made, you can't change the formula. I mean, let's put a
Okay.
box
Like
around it.
you can only make them multiple of the same thing.
Yeah. So you can't
Okay.
you, you can't touch any of them. I mean, you can't make this H3. I mean, the
Yeah.
molecule is
Okay.
H2.
Okay.
You can only have multiples. Okay. So there are two
Okay.
Cls over here.
Mm.
So multiply this by,
Two.
and there are two hydrogens now over here,
Yeah.
and there are two hydrogens already there. So it's a balanced equation now.
Yeah. Okay.
So Rafif, your turn now. Try reacting Mg with some other acids like sulfuric acid.
Okay.
Mg with phosphoric acid as well. And aluminium with hydrochloric acid. Forget the balancing, just make the formulas first.
Okay. Do I write it down, right?
Yeah.